Hello everyone and welcome to our today's class. It is our first lesson on the topic heat transfer. So let me start by giving you the quote of the day, which states that today everyone wants the results, but no one is willing to go through the process of getting those results. This is what I mean. You ask a random person, do you want to be successful? They will tell you yes. But if you ask them, are you willing to go through the steps that will take you to the success, they will tell you no. But I'm sorry to tell you this, there is no elevator to the top. You have to go through the stairs. So let's look at heat transfer. So heat is just a form of energy. Then to transfer means to convey or to move or to pass something from one point to another. So here we'll be looking at various modes of heat transfer. So let's start by defining what we mean by heat. Now, what is heat? Heat is a form of energy which passes from a body at higher temperature to a body at a lower temperature. A form of energy which passes from a body at a higher temperature to a body at a lower temperature. Now, the SI units of heat is actually what we call the joule. Remember, heat is a form of energy, so the SI unit for energy will be the same as the SI unit for heat, which is the joule. Now, where are we deriving these units called the joule? Now, remember, heat is emanating from what we call thermal energy. Heat is originating or emanating from thermal energy. Now, thermal energy was first discovered by a British scientist, that is a physicist and a mathematician, who was called James Prescott Joule. So because of his third name, James Prescott Joule, because of his third name, that is Joule, that is where we derive the units for energy or heat, which is simply the joule. Then we also look at, we need to define what we mean by thermal conductivity. So we have said that thermal means heat. Then conductivity is from the word a conductor. To conduct is to ferry or to pass or to convey something from one point to another. So here we'll be looking at heat conductivity. Now, thermal conductivity is the ability of a material to conduct heat. Simply the ability of a material to conduct heat. Then thermal equilibrium. Now remember that for there to be heat transfer, actually it means the two bodies which are in contact with each other, they have to be at different temperatures. For example, one body should be at a higher temperature, then the other one at a lower temperature, so that heat is transferred from a body with a higher temperature to a body with a low temperature. Now, there is another case scenario whereby the two bodies can be at the same temperature or at equal temperatures. So when the two bodies are at equal temperatures, it means there will be no heat transfer. Why? Because there is no what we call the temperature difference. So for there to be heat transfer, there must be a temperature difference. For example, if you have one body being at 70 degrees Celsius, then the other one at 10 degrees Celsius, the temperature difference, remember difference in mathematics means subtraction. So the temperature difference in that case will be 70 degrees minus 10 degrees, which is equals to 60 degrees. So in that case, the heat will be transferred from the 70 degrees Celsius body to the 10 degrees Celsius body. That is temperature. Heat will be transferred from a body at a higher temperature to a body at lower temperature. Now, thermal we have said means heat. Then equilibrium is from the word equal. So when we say things are at equilibrium, it means they are equal, or maybe equal forces or equal quantities are acting on those particular bodies. So thermal equilibrium, this is just a state or a condition whereby two bodies in contact with each other at the same temperature lack heat transfer between them, or is just a state or a condition whereby there is no heat transfer between two bodies in contact and at the same temperature. Then we also define what we mean by temperature. So temperature, from our previous classes, we said that temperature is actually a measure of the degree of hotness or coldness of a place measured on some chosen scale. The SI unit for temperature we did say is the Kelvin. It is the Kelvin. Now we have we can also look at modes of heat transfer. The modes of heat transfer. Now heat can be transferred in various modes or in various types. So we have basically we have three modes of heat transfer. You interacted with them in science, that is in primary school. The three modes of heat transfer are conduction, convection, and radiation. Conduction, convection, and radiation. Now, it is important to note that conduction and convection needs a material medium. That is, for heat to be transferred through conduction or convection, there must be a material medium, for example, air. But radiation does not need a material medium. That means radiation can actually take place in a vacuum. Radiation can take place in a vacuum. So let's discuss the modes of heat transfer. So the first one is what we call conduction. Now we need to define it. What do we mean by conduction? So conduction, this refers to heat transfer through solids, that is mainly in metals, is the process of heat transfer in solids, that is mainly in metals. Now, how does it take place? When a solid is heated, its particles or the molecules gain what we call the kinetic energy. Remember, kinetic energy is the energy in motion. Now, when the molecules within a solid gain the kinetic energy, they vibrate at fixed positions. That is, they vibrate in such a way that they move forth and back, sideways and sideways. So as one particle vibrates, it gets in contact or it hits the particle next to it, thus transferring heat to that next particle. So the process of transferring heat continues from one particle to another until heat is transferred from one end of the solid to another. It is also important to note that during conduction there is no movement of the material itself. The material itself do not move because particles vibrate at fixed position. So let's look at the factors affecting thermal conductivity. That is what will determine the amount of heat that will be transferred from one point of a solid to another. Now, there are four factors that affect thermal conductivity. So let's discuss the first one. So the first factor affecting thermal conductivity is what we call the temperature difference. Between the ends of the conductor. So the temperature difference between the ends of the conductor. Now, what do we mean by this? The larger the temperature difference, the more the thermal conductivity. The smaller the temperature difference, the smaller the rate of what? Thermal conductivity. So we have said that temperature difference means that one body should be at a higher temperature than the other one at a lower temperature. For example, if you have one body, maybe a metallic material, heated to 100 degrees Celsius, then the other metallic material which is in contact with it is heated to 20 degrees Celsius. In that case, the temperature difference will be 100 minus 20, which is 80 degrees Celsius. So in such a case, there will be a higher thermal conductivity. But if you have a body being at 50 degrees Celsius, then the other one at 40 degrees Celsius, the temperature difference in that case will be 50 minus 40, which is 10 degrees Celsius. So because the temperature difference will be small, it means in that case the rate of thermal conductivity will also be low. So the larger the temperature difference, the more the thermal conductivity. Now, the second factor affecting the rate of thermal conductivity is what we call the length of the conductor. Remember, thermal conductivity means that heat has to be transferred from one end of the conductor to another. So if the heat is moving over a longer distance, it means more heat will be lost on the way before it reaches the other end. So automatically, the longer the conductor, the lower the thermal conductivity. Then the shorter the conductor, the faster the thermal conductivity, or the more the thermal conductivity. Remember, thermal conductivity, that is through conduction, takes place in two processes. One, by either vibration of molecules, or two, by the movement of the mobile ions. No, by the movement of mobile electrons. Now, the third factor affecting thermal conductivity is what we call the cross-sectional area of the conductor, or what we call the thickness of the conductor. So remember, if a material has a larger cross-sectional area, it means it is actually thick. So thicker conductors have many number of electrons per unit area. Remember, those electrons are responsible for heat conduction from one point of the conductor to another. So the more the electrons, the more the heat transferred. Therefore, we are saying that thicker conductors will conduct heat faster than thin conductors. Reason being, thicker conductors or conductors with a large cross-sectional area will have more number of electrons per unit area, which are responsible for heat conductivity. Then the last, or the fourth factor affecting thermal conductivity is what we call the nature of the material. So obviously different materials have different rates of thermal conductivity. For example, the rate of thermal conductivity for iron and maybe glass are different here. So if a conductor is made of iron, it will conduct heat faster than a conductor made of maybe other materials, for example maybe silver, maybe glass, or even wood. So we look at different types of what? Materials. So those are the four factors affecting thermal conductivity. So we also look at what we call good and poor conductors. So good conductors, these are materials that allow heat conduction, that is from one point to another. In most cases they are metals. Most metals would be good conductors of heat. Then poor conductors of heat, or what we call the insulators, these are materials that do not allow heat transfer, or if they allow heat transfer, it is only by a small magnitude. So examples of insulators include rubber, wood, and plastics. But examples of good conductors, they are most metallic materials. For example, we have iron, we have aluminium, we have silver, etc. Now we also look at why are metals said to be good conductors of heat. Why are metals good conductors of heat? So the reason is because we said that heat conduction in solids is due to either movement of the molecules or vibration of the molecules, or movement of the what? The mobile electrons, or movement of the mobile electrons. So conductors, in most cases the metals, they have what we call the free or the mobile electrons. So those electrons are responsible for heat conduction. They are responsible for heat conduction. So most metals are good conductors of heat because they have free or mobile electrons which are responsible for heat conduction. Whereas non-metals, that is in most cases like maybe plastic or glass, they lack the electrons which are responsible for heat transfer. Therefore, because they lack the electrons, it means they will have a very low rate of heat conduction. That is, their conduction will only be based on the vibration of the molecules, which of course is low, So we also look at here is a table showing the order of decreasing thermal conductivity. So here are good conductors, then here are also poor conductors or insulators. So silver will have a higher rate of thermal conductivity, followed by copper, followed by aluminium, brass, zinc, iron, lead, and lastly mercury. So it means the rate of thermal conductivity in mercury is lower than in silver. Then for poor conductors or insulators, concrete has a higher rate of thermal conductivity than glass, than brick, followed by asbestos paper, rubber, wood, water, and air. So that means although these are insulators or poor conductors of heat, but some of them conduct heat to a small magnitude. For example, concrete will conduct some heat, but you cannot compare the rate of heat conduction for concrete and metal like copper. Obviously, copper will have a higher rate of heat conduction because it has the mobile electrons. Lastly, we look at a few experiments comparing thermal conductivities of different materials. So here we have an experiment comparison of thermal conductivities of wood and metal rod. So we are taking a case study of iron rod and wooden rod. Remember, wood is an insulator or a poor conductor of heat, whereas iron is a good conductor of heat. So this is an experiment to demonstrate that some materials will conduct heat faster than others. So in this experiment, we take a piece of paper, then we use it to wrap the wooden rod, then on the other end we also wrap it with the iron rod. So we arrange the apparatus as shown in this diagram. Then we take a Bunsen burner or even any other relevant source of heat. It can also be a candle. Then we burn the piece of paper for some minutes, for maybe like 5 minutes, and then observe what happens on the end of the piece of paper connected to the wooden rod and the end of the piece of paper connected to the iron rod. So when the piece of paper is burned slightly, it is observed that the end wrapping the wooden rod, that is this end here where the piece of paper is in contact or is wrapping the iron rod, this end appears to be charred or blackened. Charred or blackened. But whereas the end having the iron rod, it remains the same. That is, it does not appear burned or charred or blackened. Now the question is, why does the end connected to the wooden rod get charred or blackened, whereas the end having the iron rod is not charred? So the reason is simple. Remember, when the piece of paper is burned slightly, the end having the wooden rod gets charred because a wooden rod is a poor conductor of heat. Therefore, it means that that heat, it is the one that is responsible for burning or blackening or charring the end connected to the wooden rod. On the other hand, or conversely, an iron rod is a good conductor of heat. So immediately the heat gets here, it is conducted away by the iron rod. Therefore, it means there is no heat that will be responsible for burning this end or getting it blackened or charred. So this simply shows that iron is a good conductor of heat than wood. So the end gets blackened or charred because wood is a poor conductor of heat. Therefore, it does not conduct away the heat. Therefore, that heat is used in charring or burning the end of the paper that is connected to the wood. Whereas iron is a good conductor of heat. Therefore, it conducts away heat. Therefore, this end remains unburned because there is no heat to burn it. It is conducted away by the iron rod. A similar experiment can be carried out now using a splint, a burning splint, and some maybe a wood and maybe another metal. For example, it can also be iron or copper or aluminium or any other relevant metallic material. So in this experiment, of course, the apparatus required are those one. We need a source of heat, for example, a Bunsen burner, that is to initiate the flame. We also need a wooden material or any other relevant poor conductor of heat. It can also be glass or any other insulator. We also need a metallic material or a good conductor of heat. So in this experiment, the apparatus are arranged as shown in this diagram. Then the splint is burned. That is a flame. It is burned on one end such that it produces a flame here, also a flame here. Now in this experiment, it is observed that when the flame burns the splint up to the edge of the wooden block, then this flame also burns the splint up to the edge of the wooden block. It is observed that when this flame reaches the edge of the wooden block, it continues burning the splint until the end. Whereas when this flame reaches the edge of the metal, that is when it burns up to this edge of the metal, it is observed that this flame actually extinguishes. It extinguishes or it goes off. Now the question is, why does the flame extinguish for this case and it continues burning for this case? So the reason is simple. Wood is a poor conductor of heat. Therefore, it means that the heat of the flame will continue burning the splint because it is not conducted away by the wood, which is a poor conductor of heat. Whereas when the burning splint, when the flame reaches the edge of the metal, remember most metals are good conductors of heat. So the heat of the flame is conducted away. That is what causes the flame to extinguish. So it is because metals, e.g. iron, are good conductors of heat. Therefore, when the burning splint reaches at the edge of the metal block, the metal block conducts away the heat. So when the heat is conducted away, then the flame will automatically extinguish. So we've actually come to the end of our class today, but we need to discuss the quote of the day. So the quote of the day was talking about people wanting the results but not willing to go through the process. Yeah, it is our belief that there is a way in which some people have special talents or go to the top easily, but that is not true. If you want to achieve anything, significant in life, it is pure hard work, dedication, consistency, determination, and self-belief. There is nothing like overnight success. Yeah, anything significant in life takes time. I'll give you an example of one of the best footballers in the world called Cristiano Ronaldo. If you ask any young footballer that whom do you want to be, or do you want to achieve the success of Cristiano Ronaldo, they will tell you, yes, I want to be the best player in the world. But if you ask them to go through the training, the discipline, the dedication that Cristiano Ronaldo goes through to produce the level of performances that he produces on the pitch day in, day out, very few people will be willing to go through it. So what I'm saying is that there is no shortcut. If you want the best, you must be willing to do your best. Remember, I said there are 3 things you have to deny yourself for success to come. 1, your time will have to be used, your money will have to be used, and your energy will also have to be used. And remember this, nothing will change unless you change. And a person who wants to do something finds a reason for doing it. But a person who doesn't want to do something finds an excuse for not doing it. So if you want to achieve anything in life, please don't give excuses. Don't give excuses. Start looking for reasons why you want to do what you want to do. Because immediately you look for excuses, you are telling your conscience or your body that I don't want to do that one. Even in life, if you ask someone to help you with something, then they give you an excuse. In some cases, they could actually not be in the ability to help you. But if someone has the ability to help you, but you ask them for their help, then they give you an excuse, just know at the back of your mind, they didn't want to do it. But if you ask someone to do something, then they are not in a position to help you, but they still look for reasons to help you, then it means they really wanted to do it. So a person who wants to do something finds a reason for doing it. A person who doesn't want to do something finds an excuse for not doing it. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.